Hey guys, Sarang here. Welcome back to the final part of this tutorial series. In this part, we are going to look into how we can implement this ring of orbs to control our lights. We are going to look into how we can use RealityKit animations to smoothly animate the insertion and removal of the orbs into the ring, creating these graceful effects in your app just using RealityKit. Before we dive right into it, the link for the GitHub repo is in the description, so don't forget to check it out. If you haven't watched the first three parts, they were equally exciting. Part 1, we covered world anchors and how we can use them to create persistent light control entities that can last across reboots. In part 2, we created a very simple light control UI to set the colors on the light. In part 3, we looked into how we can create a slingshot mechanism to get more playful and control the lights with a slingshot and a projectile. So if you haven't already, don't forget to check it out. I have learned a ton making these videos and working on this project, and I really hope that you have too. If you like the first videos and my other videos, please subscribe to the channel. It means a lot to me. Now, let's get into it. Let us begin in our app model, where we'll be adding a new light control mode. We'll call it Orbs on Hand. Then we'll go to our content view. In our content view, we'll add a new button. We'll call it Ring of Orbs, and this button will allow us to change to this newly created mode. You can see this is how it will look. Let us now take a look at the changes we'll be doing in our hand tracking manager. If you remember correctly, our hand tracking manager initializes the hand tracking provider and then delegates specific gesture detection tasks to other managers. Previously, we delegated the piece gesture detection to Slingshot Gesture Manager. Here we want to detect whenever the user does a palm up gesture, and that's what the Orbs on Hand Gesture Manager will do. If we look at the init function over here, we are initializing the Orbs on Hand Gesture Manager whenever the user changes the mode. We can handle this in this callback of on light control mode change. So here we are initializing this new gesture manager and deinitting the old one. Same thing happens whenever we go to the slingshot mode. At the bottom, we have our monitor gestures function, which gets called whenever our immersive view appears. You can see here previously we were just calling monitor piece gesture, and now we are also calling the monitor palm up gesture on our Orbs on Hand Gesture Manager. This introduces a very interesting bug that we are going to solve. Let's see what we are doing in our immersive view. In our immersive view, we have this task modifier where we are calling monitor gestures function in hand tracking manager. Since we are calling monitor gestures only when the view appears, you can see that if we select Ring of Orbs or Slingshot and then we click show immersive space, you can see that our slingshot thing appears. But if we switch to a different mode, let's say Ring of Orbs, our gesture is not working. If we hide and then switch the mode and then show immersive space, then our gesture gets detected. But if we switch back to slingshot, it's not working. So we'll have to go out of immersive view and then come back into the immersive view so that your mode change is successful. And this is a problem. Let me show how to solve this. To solve this issue, we need to remove our monitor gestures function call from the task modifier in our immersive view and move it into our hand tracking manager. In our hand tracking manager, we have a callback for whenever the light control mode changes. And this is the perfect place where we can call monitor gesture. One issue with this is that every time you call monitor gestures whenever the mode changes, you spin up a different task. Which means that if you have multiple tasks that will call monitor gesture, you will see artifacts like multiple orb rings getting created or multiple projectile entities getting created in the app, and we don't want that. That's why I'm creating a gesture monitoring task variable, and in that I'm saving this task. So every time the mode changes, we cancel the previous task and we create a new one, and this cleans things up. There's another bug with our code here. If your entities for a particular mode are showing and then you switch the mode, then your entities will not be destroyed. it will happen to all your modes. So here I am showing the ring of orbs, and then I switched to slingshot mode, and now everything is broken. For our issue of entities not getting destroyed, the solution is very simple. We can simply call the functions that destroy the entities for each gesture manager. So we call the remove entities for fingers and projectile for the slingshot gesture manager, and we call remove orb ring for orbs on hand gesture manager, and that removes the entities whenever there is a mode change. And this should solve the problem. Now let's take a look at orbs on hand gesture manager. This is the most important class in this tutorial. We'll be spending most of our time understanding what this class does. This class does a lot of things. Primarily, it detects whenever the user does a palm up gesture. When the user does a palm up gesture, we then create the ring of orbs that we are visualizing to the user. And then the user can manipulate individual orbs in this ring, and they can add it to the ring, remove it from the ring. So all of that is handled in this class. When we initialize this class, we get a reference to the hand tracking provider over here. So we are not instantiating it. Then I have some variables that store the created orb spheres into a model entity array. Then we have our parent entity here, which is the orb ring entity, which gets added to our app model's content. And then we have the child of the orb ring entity, the animated ring entity, which we are doing all the animations on. We have some flags here. Then we have this array of tuples here that defines the hue, saturation, and brightness values and the UI equivalent of the hue for all the orbs we are going to create. So we are going to create as many orbs as we have the tuples in this particular array, and these also define the colors for the different orbs. The monitor palm up gesture is the most important function over here. You can see I have defined some variables here to improve the stability of the tracking of the palm up gesture. We'll talk about how they're used in a bit, but most important thing it's doing here is awaiting this hand tracking updates. Our hand tracking provider provides us all the hand tracking updates. Here we check if our anchor is tracked and if we can get the skeleton from the tracked anchor. Then we check the anchor's chirality, which is the handedness. So here I only want to track for the left hand, so I'm checking if the chirality of the anchor is left. Then from the skeleton, we get the middle finger metacarpal, that is the closest representative of the palm joint, and then we check if the palm joint is tracked. We discussed this before in the previous tutorial, but the anchor origin from anchor transform gives us the world space location or world space transform of the anchor, but the palm joint anchor from joint transform only gives us the transform relative to the anchor. So we need to do a matrix multiplication between these two transforms to get a world space transform for the palm joint. Once we have the world transform for the palm, we can then extract the rotation from it. Once we have that rotation, we can apply this rotation to the local up vector. Here the 0, 1, 0 is a local up vector, the direction perpendicular to the palm surface. After applying the rotation over here, the palm up vector basically tells you where that direction is pointing in the world space. Then we have defined a threshold here that acts as a trigger to detect when our palm up vector is facing upwards. So when the palm up vector's y value is close to 1, that means it's pointing upwards. When it's close to -1, that means it's pointing downwards. And when palm up vector's y value is close to 0, that means the palm is sideways. So here, when it is greater than 0.5, that means the palm is relatively facing upwards, and here we start updating the palm up stable count. When that value is less than the palm up threshold, we basically set the palm up stable count to 0 and start updating or incrementing the palm down stable count. Whenever either the palm up stable count or palm down stable count reaches a required stable count that we have defined here as 3, we trigger a particular gesture. So when the palm up stable count goes above 3, that means the user is doing a palm up gesture, and now we can do whatever we want to do when the palm up gesture is detected. So when we detect a palm up gesture, we create a new entity and assign it to the orb ring entity, and then add that orb ring entity to our app model's content root. Our app model's content root is then added to our immersive views content, and this is how this one line of code is responsible for visualizing anything that is the child of the orb ring entity. Now that we have created our orb ring entity, we have to assign it a position. We already have our palms transform from which we can get its position. Once we have that, we are going to add an offset of 0.2 meters to the palm position, and that will become our ring's position. Then we create a transform with this newly created position and then assign it to the orb ring entity. And then we create the animated ring entity over here. The animated ring entity is going to contain all our orbs that we are going to manipulate. The animated ring entity is also going to be the one where we apply our scale and rotation transformation so we can animate things gracefully. So why did I separate things into the orb ring entity and the animated ring entity? So you can see here that our orb ring entity has some billboarding transformations happening on it. So you can see here that I'm calling app models get current device transform to get the camera's transform, and then from that I'm extracting the camera's position, and then I'm calling the orb entity's look function to make it look at the camera position. So the orb ring entity has a billboarding transformation on it. Now if the animated ring entity and the orb ring entity weren't separate, and if the billboarding transformation and any animations we are applying to the animated ring entity are happening together, then you'll see weird artifacts due to multiple transformations getting applied simultaneously to the same entity. What I saw was the entity was trying to scale and also billboard at the same time, so it was vibrating. And this is not the intended behavior. So to remedy this, I had to separate this into separate entities. So one is only responsible for billboarding, other one is responsible for all the other animations. Speaking of billboarding, you can see that I'm manually doing the billboarding here. And I did try using the billboard component that is built into RealityKit, but I'll explain it later why this was not a good approach here when I was trying to manipulate the individual orbs. So we'll learn about that a little bit ahead in this tutorial. So for now, my recommendation would be just manually get the camera's transform and make the entity face that transform. So when the animated ring entity is getting created, we have to do a bunch of things to it. So first thing we are going to do is going to set it up for animation. So when it gets created, we are going to set its scale to 0.001. And then we are going to set its rotation. We are going to rotate it by 90 degrees on the z-axis. And definitely we should not forget that we need to add this to our orb ring entity. Then we'll call these two functions create of spheres and arrange of spheres. What create of spheres does is creates the individual spheres that we are going to add to this ring. And then the arrange of spheres is basically arranging these created spheres in a ring. So when the user does a palm up gesture, we want to show a nice animation of the ring of orbs appearing and scaling up. And this animation should have a nice curve to it. And here we are using the animated ring entity's move function and giving it a target transform. So what this does is it tells please do this animation for 1 second. The timing function we are using here is cubic Bezier, and we are giving its parameters as control point 1 and control point 2. These values basically come from experimentation, so you can see how the curve should look like with these values. These were the values I kind of settled with. But when this function is called, we need to provide it a target transform. So we are setting the scale back to 1 and then the rotation back to 0. So here, if you remember, We set the scale to 0.001 on all three axes and rotated it 90 degrees. We're basically reverting that. So we'll definitely look into creation and arranging of the off spheres because they are really the fun ones. But first see what happens when the user is not doing a palm up gesture. In this case, when our palm down stable count meets or exceeds the required stable count, which is 3 here, we are basically detecting that the user is not doing a palm up gesture anymore. So when we detect that the user is not doing a palm up gesture anymore, we are basically animating this animated ring entity to a target transform. The target transform is going to be again a scale of 0.001, and then we are setting the duration for this animation to 0.5 and the timing function to ease out. When this animation completes after 0.5 seconds, we are removing the orb ring entity of spheres from their parent. So it clears and basically destroys everything and the ring disappears. So since the animation is going to take 0.5 seconds, we need to make sure that this animation doesn't get triggered again. That's why we have this flag called is closing ring. And whenever we detect that the user is doing palm up gesture, we set is closing ring to true, and then we only set it to false when the animation completes, so this function call doesn't get executed multiple times. So now let's take a look at what actually happens when we create the orb spheres and how we can arrange them. Creating of the orb spheres is very straightforward. So creating a mesh resource by calling the generate sphere function with the radius of 0.02. So this is going to be our orb. We are initializing the orb spheres array with an empty array, and for each item, each tuple in our predefined colors array that we looked at, so I think there are 8 colors in it, we are going to create a orb component. We are going to assign the hue, saturation and brightness value to the orb component based on the color we have in predefined colors. We are going to create a physically based material, and then we are going to generate a normalized hue, saturation and brightness value. So we did this for the projectile as well. And then we are also going to set its selected UI color over here and then assign the orb's emissive and the base color property of it to the selected UI color over here. We set its roughness to 0. Then we create a sphere entity, which is going to be a model entity with our sphere mesh and the orb material. We assign input target component and collision component here so we can manipulate the spheres or the orbs. And then we also finally assign the orb component to the sphere entity. And we finally, once we have created one orb, we append it to our orb spheres array. And then finally, we add that created orb as a child of our animated ring entity. So we have to do it for every single item in our predefined colors array. So that's how many orbs will be in our ring. So you'll see that we created an orb component. So let's quickly take a look at what this orb component is. So the orb component will look very familiar to you. It has a hue, saturation and brightness value and has been manipulated flag. And yes, it looks exactly like our projectile component. So it is just a way to identify and store some information here. So we are doing the exact same thing. We are saving the hue, saturation and brightness values that we'll be using to change the color of the light eventually. So we are storing that information in the orb component here. So we created the spheres. Now we need to see how we can arrange them into a ring. For that we have the arrange orb spheres function. You can see that there are some variables here like empty slot index. We don't need to look into it right now, but when we'll be manipulating individual orbs like removing and adding them back to the ring, this is exactly when we'll be needing these. So just ignore these for now. Just understand that our total number of spheres is going to be the amount of spheres we added to the orb spheres array in the create spheres function. Our total number of positions we are going to have in our ring for our orbs is just going to be the amount of sphere count we have. So here we check if we have total positions greater than 0. If not, then we simply return. We set a ring radius of 0.075 meters, so it's not super big. Then we start a sphere index that starts from 0, and then we create a for loop that goes from 0 to total number of positions. Here what we are doing is we are calculating an angle. So the angle will be calculated by 2 times float pi divided by total number of positions. So we are dividing 360 degrees by the total number of positions, and then we determine the angle of the current insertion or the current position by multiplying it by I. And then we use some trigonometry to determine the x and y position of our sphere by using the cosine of the angle times the ring radius and the sine of the angle times the ring radius. This will give us a target position by instantiating a SIMD3 float by passing the xy position and 0 for the z-axis. Once we create the position, we need to assign it to our entity, and we can get our entity from the off-spheres array by passing the sphere index. So we'll simply set its transform and initialize a new transform by passing the target position. And this is how we set the position on the sphere when it gets created, the ring gets created. So we increment the sphere index and we repeat the loop, and that's how all the other spheres will be positioned. So we are incrementing the angle value, getting the new xy positions, and then keep on creating the new spheres. Now let's see how this will look when we run it. So when we run this, when I do the palm up gesture, the ring of orb appears. You can see how subtle the animation is. If you remember, we have a scale animation on appearing of the ring that we have set on our animated ring entity. And we are doing 2 transformations. One is for the scale and the other one is for the rotation. So you can see how the cubic Bezier curves subtly animates the ring's appearance. And then we have an ease out animation for when the user kind of does a palm down. And it all looks very beautiful. You can also see the billboarding in action over here. As I'm moving my hand left to right, you can see the ring of orbs is facing me. It also faces me when I move my hand up and down. Let us now figure out how we can manipulate these orbs by dragging them. To do this, we'll go in our immersive view and we'll set up a drag gesture on our reality view. Our drag gesture will be targeted to our entity with the orb components or orbs. Then here we are getting the value of the gesture and get its location. We convert that location from the local space to our orb's parent entity, and then we assign that new position to our entity, and this is what will manipulate our entity. Then we call this function update drag orb in the orbs on hand gesture manager, and we pass our orb entity that we are manipulating as a model entity. We'll look into this function in great detail, but before that, we need to change the parent of the orb. So if you remember, when our orb gets created, the animated ring entity and the orb ring is the parent. So what happens when you're trying to manipulate this orb? If your hand that has the orb ring moves, it causes a problem where your manipulated orb moves with it. So we need to change its parent. So here what I'm doing is I'm changing the orb component has been manipulated flag to true. We have this flag only because we want to change the parent when we begin manipulating the orb. And then I change the parent of the orb entity to content root. When the gesture is ended, that means you're releasing the drag gesture. We call the onSphere released function on the orbs on hand gesture manager. And then we pass the orb entity to it. Let us first see a demo of what happens when I begin manipulating the orb. When the manipulation begins, you can see that the other orbs are leaving a room from where this orb was removed. I'm measuring the distance between the center of the ring and the orb that is being dragged. There is a threshold at play here, so when I drag the orb beyond a certain threshold, the other orbs take up the space. When the orb gets closer to the ring, you can see that the other orbs will move and make room for this. So this is like an empty slot that will insert this orb. Now when we are trying to release the orb, if we release the orb outside the ring, you can see that it's not a part of the ring anymore. When I release it inside the ring though, it becomes a part of the ring again. Let's take a look at how this was implemented. All of this behavior that we saw is implemented in the update dragged off function. Let's dive deep into it. In the update dragged off function, we'll first get the ring center, which is the world space position of our orb ring entity. We can get the world space position by using this function position relative to and setting the relative to parameter to nil. Similarly, we get the world space position of our dragged orb. Now we can calculate the distance between them using simply distance, which uses the distance formula, and here I'm using a threshold of 0.15 meters. Then we want to get the local position of our dragged orb relative to our orb ring entity, and we can get that using our convert function. Once we have that local position, we can calculate an angle using the arctangent 2 or the ATAN2 function by passing it the x and y coordinates of our local drag position. The ATAN2 function will give us an angle from the positive x-axis. The angle is given in radians and its value could be minus pi to pi. So we'll have to normalize it. When we normalize it, the value gets converted to 0 to 2 pi radian or 0 to 360 degrees. And based on this angle from the x-axis, the positive x-axis, we can now determine, depending on the angle, where is the insertion index of the orb, depending on where it is relative to the ring entity center. When the user begins manipulating the orb, it's going to be near the ring. So this part of the code will be executed first. So here, we first remove our orb that we are manipulating from our orb spheres array. Then we want to leave an empty slot at the position from which it is getting removed. So we compute an insertion index, which basically tells us at which exact spot this particular orb was. We'll look into this function in a bit, but then we'll call again our arrange of spheres function that we have looked into previously. And here we are going to set the animated flag to true and the empty slot index to our insertion index. This is what creates the empty slot there. Let's take a look at this function. So this time when we call arrange of sphere, we want to leave an empty slot from where we have started moving our orb. So what we are going to do is we simply add 1 to the number of spheres that we are getting from ospheres.count, since we have already removed our sphere that we are dragging. Now when this for loop executes, we simply check whenever our I value matches the empty slot index, we basically skip this particular iteration of the loop. That means we don't simply add anything. So when our I increments for the next one, we directly go to the next sphere that we are going to lay, and that creates a gap in the layout of the spheres. You'll also see that this time we are setting our animated flag to true, which means we are calling sphere.move function, and here we are animating the spheres to their target position within the animated ring entity. The duration for this animation is going to be 1 second, and we are using a cubic Bezier curve with some control points which came from experimentation and what felt right. So because of this animation, you'll see the nice smooth motion of the orbs kind of moving and then kind of going close to each other whenever the orb is getting manipulated. Now, let us see how we calculated the insertion index based on the drag angle that we are getting. In the compute insertion index function, we are passing the current sphere count. Remember that we just removed a sphere from the spheres, right? So now we need to add 1 to the sphere count. So here I'm creating an array of floats which is going to give me the angles for each position. So for as many spheres we have in our ring plus the empty slot, we are going to iterate over it, and then we are going to calculate the angles for each position by using this formula. All this formula is doing, it's basically dividing 2 pi, which is 360 degrees, by the total number of spheres we are going to have. And when we multiply that with the I, which is going to be the current value of the iterator, we'll get a current angle for the current index, and we're simply appending it to the ideal angles array. And then we simply iterate over the array of the ideal angles and compare for each index where do we get the smallest difference for the drag angle and the angle for the current index. Wherever this difference is going to be smallest, comparing it with all the elements of this array of ideal angles, that is going to be our best insertion index. So that is how we handle when the sphere is near the ring. But when the distance gets greater than the threshold, we are simply doing the same thing where we'll find the index of our dragged orb and then remove it from our orb spheres array if it's not already removed. And then we simply call arrange of spheres, and this time it will not leave a gap. And since this time we are calling arrange of spheres without passing an empty slot, the rest of the orbs will smoothly animate to fill up the spot of the orb that we just removed. And that is what update dragged orb is doing. So when our drag gesture is ended, we call the onSphere released function. OnSphere release is going to do very similar things compared to what we were doing when we were dragging the orb actively. So again, we are getting the positions for the orb ring and the sphere that we are dragging. We are calculating the distance. Here I have set the threshold for the release a little bit lower. So it's going to be 0.12. And then I'm doing the same thing. I think the simple case is going to be whenever the distance is greater than the threshold. So that means we are leaving and releasing the orb outside the ring. And in this case, we simply do nothing. So what will happen is our content root is going to be the parent for our dragged orb, and the dragged orb doesn't move with the ring anymore. It's kind of just a floating entity. Then we just need to handle what happens when our distance is less than our threshold. So now when the distance is less than the threshold, this means that we are releasing the orb close to the ring. Now we are doing very similar things where we are getting the local position relative to the orb ring entity, getting its angle, we are normalizing that angle, and then we are again computing our insertion index, and then we check if the sphere is not the part of the orb spheres array, then we simply insert the orb sphere at the insertion index. So now that we are inserting our orb back into the ring, we have to make sure that the animated ring entity is going to be the parent of our sphere, and this is what this line of code is doing. If our orb was already a part of our orb spheres, then we try to get its current index, and then if we see if the current index matches the insertion index that we found. If it does not match, we remove the orb from the current index, which is the older index now, and then reinsert it at the new insertion index. Then we again call arrange of spheres, set its animated flag to true, and since we are putting our orb back into a ring, we have to make sure that we are disabling the has been manipulated flag to false, and make sure that we are setting the orb component back on the sphere once we have changed this flag. And that is it. That is all the code we need to handle the manipulation of the orb. Alright, so this is the perfect time to talk about why I stopped using the billboard component for this particular use case. So let's try something. Let's just uncomment this line where I'm using the billboard component and comment out my code for billboarding, and let's run this. So when I show my orbs, and when I try to add them, you can see that the slots are actually getting created at the right spot. But let's say if I rotate and then I try to create the slots, you can see that the slots are not getting created at the right spot. Why is this happening? So why is this bug? And I really headbanged a lot to figure out why this was happening. So you see, it's not opening the slot at the right spot, and I checked my calculations twice and thrice, it was not working. And this issue is being caused by the billboard component. Let's see why. So the reason this problem is happening is because when you use the billboard component, you can see, so I digged into Apple's documentation and there was this line there. Okay, entity with billboard component doesn't provide access to its end orientation. Requesting the entity's orientation through its transform returns only the unaltered rotation. That means if you are using a billboard component, it doesn't actually change the rotation when you try to get the rotation of the particular entity with a billboard component. It's only for visualizing, and that is exactly why this problem was happening. So keep in mind, if you want to do billboarding and again try to get the entity's rotation, you have to manually do it. That's what I'm doing over here. This is very important. Let me show you one more problem. So you know that the palm up gesture is actually a visionOS system gesture, right? So when I show the ring of orbs by doing a palm up gesture, the visionOS menu button also pops up. There are a couple problems this causes. For example, in this particular case, when I try to drag the purple orb, it doesn't let me select it, or the blue one, also not the pink one. So this is the problem. There is a subtle fix to it, but UX wise, please avoid the use of the palm up gesture so you don't interfere with the system gestures. But there is a way we can hide this button. Let's check it out. We can actually hide the system overlays by adding a view modifier to your reality view. It's called persistent system overlays, and then we can set its visibility to hidden. When we do that, so now when we do the palm up gesture, we don't see the system button. We just see our beautiful orbs, but the button is still there. It's just hidden. So if you try to manipulate the orbs now, you cannot still manipulate the bottom three orbs. The blue one you can, the red one you can, but the pink one, the blue one, or the purple one is not. And you can see that the button appeared when I did a tap gesture on it. So it's just hidden, and it can appear when the user really tries to access it. So keep this in mind. It's not disabling it, it is hiding it. Alright, now we are at the very final part of this tutorial. Let's see how we can use our orbs to control the lights. We've done this when we did the slingshot mechanism, and we are using the exact same thing to control the lights here, collisions. So you can see that I have the orb collision system over here. So the main thing happening here is in the update function. The update function happens every single frame. So we check if we are in the right mode, if not we just return. But then what we are doing is we find all the orb entities with the orb query. The orb query basically check if your entities have the orb component or not. Then we clear out the cancellables array, so then we basically clear out all the subscriptions we have previously set, and then we create new subscription on every single orb that gets found. Here we are subscribing to this event of collision began, and whenever that collision happens, we get the entity A and the entity B. In this case, the entity B is going to have light control component, and our entity A is going to be the orb. That's why it has the orb component. So when the collision happens, this closure executes, and all we do is use our Hue control manager control light or control group function, and then from the orb component, if you remember, we save the hue, saturation and brightness values. So we are simply passing that in the control light or control group. So here we can pass the light name, from the LCC or the light control component, and the state we can set from our orb component. So orb component provides us the hue, saturation and value, which is going to be the hue, saturation values of the orb, and then we set it to the light. And that's how when we drag an orb from our ring to the light, our light changes color. One last thing we need to do is that in our light control tutorial app file, we need to register the component and also register the orb collision system. Without this, the collisions won't be detected, so please don't forget about this. Now let's run this one final time. Now when I do the palm up gesture, the ring of orb animates and appears very beautifully. And when I drag and drop the orbs on the lights, the light takes the color of the orbs I drop. Alrighty everyone, that brings us to the end of this series. There's a lot of content we covered. Primarily, we learned how we can use ARKit world anchors to create persistent AR experiences in your Apple Vision Pro apps. I certainly had a lot of fun and I learned a lot while I was making these videos, and I hope you learned a thing or two. If you did, please make sure to like the video. The next project I'm working on is really going to blow everyone's socks off. Is going to involve ARKit image anchors, so please make sure you stay tuned and subscribe to the channel so you get notified when that one comes out. I'll see you in the next one. Ciao!